Hi everyone, welcome to our presentation for the midterm case study. In this assignment, we were given a real-world business scenario of an electric scooter company. The company has had its product in the market for about 2 years now, but it hasn't quite lived up to its expectations. Our task was to put ourselves in the company's shoes and analyze the situation and solve the issues according to our understanding. Now we have picked 8 questions from the list of questions provided and built our presentation around them. Each team member will be walking you through different parts of our analysis. We hope you enjoy our approach, and with that, uh, our team consists of, first of all, myself, that is Dhyanendra Tripathi, then Arpit Kumar Sinha, Rachit Tripathi, and Vishal Sharma. Now let's get started with the first problem. Now let's move on to the first question, which was to identify the top 10 features we would want in the app and highlight the 5 most important out of those. Now, after brainstorming and considering the issues listed by the users, here are the top 10 features we have aggregated. Coming to the first feature, which is real-time battery status and estimation. This will enable users plan their trips ahead of time without worrying about sudden battery drops and stranding them out of nowhere. Coming to the second feature, vehicle diagnostics and health monitoring. This feature will keep the users informed about their scooter's condition in real time. This will give information about the headlights, the air pressure, the battery status, etc. Coming to the third feature, which is navigation with Google Maps. Using the feature, users will be able to plan their trips ahead of time, considering various other constraints like terrain and everything. Coming to the fourth feature, which is custom driving modes. This will allow the users to tweak their riding experiences according to the mood they're driving in or the terrain they're choosing to drive in. Coming to the fifth feature, which is user achievement section. This feature will add a bit of fun and motivational elements for the users. This will ensure the user retention as well, enhancing overall user experience. Coming to the sixth feature, which is theft protection and location tracking. Using this feature will send instant alerts and live location to prevent theft. Uh, this feature also enhances user experience. Coming to the seventh feature, which is service reminders and maintenance. This feature will keep users informed of their scooter maintenance without them worrying about it manually or keeping a manual record. Coming to the eighth feature, which is ride statistics and history. This will show the data of the previous trips, like speed, the battery used, and the efficiency of the electric scooter itself. Again, very user experience enhancing feature. Coming to the ninth feature, which was a chatbot for user guidance. Now, most of the problems faced by the users are already solved, so the chatbot will solve them without involving a customer service from the server side or the company side. Coming to the 10th feature, this is community features. So the community always encourages the user retention, so social interaction and sharing their ride experiences. This is a great feature to add in the app. Now, coming to the top 5 most important features. Uh, Here is a mind map of the same 10 features we discussed earlier. Coming to the first of the most important features, real-time battery and range estimation. As discussed earlier, this will prevent unexpected battery outage, and this will eliminate the anxiety of the user of not knowing when the charge will run out and whether they will be stranded out of nowhere or not. This will also enable the users to plan their journey ahead of time and more efficiently, considering their battery and other things. Overall, this feature enhances user experience a lot. Now, coming to the second feature, which is vehicle diagnostics and health monitoring. This feature will provide real-time monitoring of the key scooter components like lights, battery, air pressure in tires. Now, on the right of the slide, you can see a concept diagram I have created using Figma. Uh, in the last PPT also, this is a concept diagram of how the real-time battery and range estimation will look like. So, this feature will also detect the potential issues earlier and tell the user about preventing any serious breakdowns, informing earlier. This also will also send alerts and notification to users about abnormal behavior detected in the electric scooter. Uh, there are various other add-ons we can add on this feature, like maintenance recommendations. Overall, this feature also enhances user experience a lot. Coming to the third of the most important features is navigation with Google Maps. So this feature comes with a lot of add-ons, like users can pre-decide the path they want to reach to an intended destination according to the set of objectives they have to complete. This also takes traffic and terrain into account, thereby resulting in energy efficient paths. Cons- Now, coming to the fourth of the important features is custom driving modes. Now, as seen in the meta, most of the electric vehicles uh, use this feature to enhance the user experiences. This will allow users to personalize their ride settings according to their mood or terrain they are following. Uh, so this feature will tackle the complaint that was issued earlier about the comfort on varied road surfaces. Um, this will also allow the users custom settings of the power consumption, acceleration, and seat orientation, etc. Now, coming to the last of the most important features is theft protection and location tracking. This user will send anti-theft alerts to notify users instantly if the unauthorized movement is detected. So this is a very user attractive feature. So if the user is ensured that there is uh, a, a security patch on the vehicle, then he will be relaxed. Then this will also share real-time location tracking uh, to help users monitor their scooter location at all times. Now, this will also open a parental control feature for the guardians of their children, using which the guardians will be able to track where their children are taking their scooter and all. This can also be used if they are lending the scooter to someone else. Now, geofencing is another add-on that can be added uh, to this feature, using which the owner can decide to move their scooter only in a defined area. Now, let's move on to the next problem, which was design considerations for document storage feature. So, uh, let's consider the architecture design considerations for the document storage feature. So, the first of all, the cloud storage with local cache for the e-scooter. The documents will be stored in a cloud storage primarily like AWS or GCP for reliable retrieval and access. Local caching should also be used on the app and the scooter itself for accessing even if the scooter or the app is not connected to the network or internet. Uh, this feature will be helpful if the app or the scooter itself is in remote areas and still want to access the important documents like the driver's license or vehicle papers and everything. Second is communication protocol. Now mostly the vehicles travel a lot, so they might happen to stranded in a remote area without internet. So low bandwidth protocol should be used for easy access even in low network areas, and there should be periodic background checks to ensure that the data is synced across all devices. Uh, Also, the data should be end-to-end encrypted during this communication protocol so that unauthorized access is prevented. Coming to the third point, which is security and privacy. The data stored on the server side and the cached data should be also encrypted so that unauthorized access can be prevented by accessing the storage device on both the electric scooter and the application itself. Um, Proper logging and audit of the unusual activity should also be done to prevent uh, any unethical activity on both sides. Coming to the fourth point, which is scalability and maintainability. Now, scalability is very important when the number of electric scooters and application users will increase. The cloud storage service like AWS and Google Cloud Platform provide such reliable scalability and maintainability. Now, this can also be ensured using microservices so that the problems can be tackled easily by focusing on the service that is not working only. Now, some monitoring tools can also be used for checking the service status. The popular cloud platforms like AWS and Google Cloud Platform already provide these features. And this is a concept diagram for the system architecture of the application and the document storage feature. So as you can see that the primary storage is the cloud itself, and the document data is being cached on the application and the electric scooter. And the features which we discussed earlier across the four top headings are as follows. Now, there are some security considerations we have to keep in mind while designing the uh, document storage architecture. As discussed earlier, the data should be end-to-end encrypted during the communication protocol and also while storing on the server and the client side for preventing the unauthorized access. Now, some of the encryption algorithms, lightweight encryption algorithms that can be used are AES or SASA20. Uh, Coming to the second point is authentication and authorization. Uh, Authentication and authorization should be required at 2 points. Whenever the user logs in to their account on the e-scooter for the first time, then the authorization and authentication should be done using a reliable authentication service like Google OAuth or something. And also while accessing the data on the scooter, the authentication should be done using a PIN or password for the local system. Uh, Another add-on that could be added for this part is using a biometric verification system, a password or a PIN. Now coming to the third point is secured API structure. Now the backend should be secure. Uh, the secure authentication and authorization can be ensured by using a secure framework like OAuth and JWT. Now OAuth is provided by the Google itself, so it's reliable and secure. And JWT is also well popular and reliable for the ensuring the session authenticity. Now the stored passwords and pins should also be encrypted so that there is no phishing from the server side or the client side. Now coming to the fourth point, that is privacy controls. The uh, the server should also should allow the fine-grained control over the document sharing and access. Coming to the fifth point is unauthorized access notification. Now the user should be notified for any suspicious or unauthorized access attempts for the document access. And now this feature ensures the user is always aware of if their account is secure or not, kind of like two-factor authentication that Google provides. Now that's it for the this part. Now my friend Arpit will continue for the next problem.
Hello, my name is Arpit Kumar Sinha, and let's move on to the third problem, which is customer complaint analysis and test scenarios. We have identified two major user issues, which are battery charging issues and app notification delays. So, the potential reasons for battery charging issues are battery degradation, which happens over time, reducing efficiency and increasing charging time. Inaccurate battery management system (BMS) may misreport battery health or charge. Firmware bugs might cause inefficient charging logic or missing low charge warning. And the last one is poor thermal management, which is either overheating or poor temperature compensation, which can disrupt performance. Now, the test scenarios which we have designed are: first, long-term charging test, in which we have to monitor charging time over 100 full charge discharge cycles, and we should verify that it is consistently less than 4 hours. Second, battery calibration test, discharging battery in 10% steps at different temperatures, and then verify its accuracy. Third is low battery warning test, in which we ensure proper alerts are shown at 15%, 10%, and 5% levels of the battery on both the app and the dashboard. Next, fourth one, thermal management test, in which we check if charging rate adjusts when battery is hot after a ride. The fifth, charging types test, in which we use both standard and fast type chargers and then confirm that system adapts to it accordingly. Last one, battery health monitor test, in which after 6 months of use, we verify if the app predicts the battery health correctly or not. Now, the next issue is notification and outdated info issue. The potential reasons might be poor synchronization between the app and server, slow API response, outdated data not replaced, that is cache issues, inefficient network handling, and then delayed server-side processing. The test scenarios which we have designed for this issue are real-time synchronization test, in which we change settings and check if the app updates within 5 seconds or not. Then offline mode test, in which we use the app with no internet, then reconnect and then test auto synchronization. Third, push notification test, in which we trigger alerts like low battery and check the delivery time, which is expected to be less than 3 seconds. Then fourth, real-time charging test, which is during charging, we verify live updates for the percentage of the battery and time remaining for the full charge. Fifth, background update test, in which we keep the app running in the background and ensure that updates still appear on the phone. Data consistency test, in which we compare the battery and ride information across app, dashboard, and cloud, even during network disruptions. Now let's move on to the next problem, which is inside-out strategy and outside-in strategy for the product release, in which we have designed these strategies for the new version of the electric scooter, which we want to release in the market. First, inside-out strategy. Now, inside-out planning means what the company can build by focusing on its strengths and its internal capabilities. The first, we can redesign the app's architecture to support real-time cloud app scooter communication. Second, we can revamp UI UX using in-house design standards, making the interface modern and initiative. Third, optimize data pipelines to ensure fast updates on battery, GPS, and alerts. Fourth, we can build reusable independent components like maps, document storage, and dashboard settings, which can come under modular feature development. Fifth, internal QA and stress testing, in which we can simulate edge cases for poor connectivity, override charging, and long rides. Then, in which we can use regression and performance tests to ensure smooth functioning. Now, outside in strategy, in which the customer focus and market alignment are in sight. So here are the 5 key actions. First, customer feedback loops. We can interview users, collect feedback, and then perform alpha beta testing on UI concepts. Second, competitive benchmarking. Analyze apps from other electric scooter companies like Ather, Ola, TVS to find the winning features and set our product apart. Third, beta testing with real users. We can release an app to a diverse user group, urban, rural, and tech savvy to gather real world feedback. Fourth, App Store readiness and review strategy. We can ensure that app complies with Play Store and iOS App Store standards, and we can prepare screenshots, videos, and plan for launch day review incentives. Last, marketing strategy. We can build hype around the solutions like smarter rides and real-time alerts, and we can use teaser campaigns and social media to attract early adopters. So now from here on, my friend Vishal will continue.
Good morning, everyone. So my name is Vishal Sharma. I will be continuing the topic. So today we will focus on the two parts. First of all, how we will use AI and vehicle data to build a smarter and more connected EV ecosystem. Second, big picture of how the EV industry has evolved and where we are headed over the next decade. I will keep it simple and relevant. Let's skip to the main PPT. So to make a electric scooter intelligent, we need to feed it data and lots of it. There are three ways of data stream. First, the vehicle itself. We monitor the battery, motor efficiency, charging cycles, and even the temperature. Two, the rider. How do they accelerate? How do they take break? What's their riding pattern? And the third one, the GPS, the environment in which we will monitor the GPS, how the road condition, traffic, weather, even the proximity sensor. This is not just a data collection. This is building a real-time behavioral and contextual model of both machine and the user. In today's industry, what they call it digital twin, and it's one of the most hottest trend in the industrial AI right now. So what we can do with this data and why we are going to use the data, let's discuss. Because data without action is just a noise. So our app is used to generate the data, real-time data, meaningful recommendation for three areas. First of all, efficiency recommendation. Riding efficiency, the app might suggest the optimal speed to conserve the battery or smoother route based on terrain and traffic. Second one, predictive maintenance. Instead of fixed service intervals, we notify the rider based on actual uses. Third one, the safety, the most important one. Imagine being warned about the sharp curve ahead or nudged to take a break if you are riding too long. It just might save your life. Three, these insights directly impact the customer satisfaction, overall operating efficiency, and the brand loyalty. I think these are the main brand pillar of the consumer mobility. By this, we can increase the overall sales. So let's now discuss more. Let's discuss the role of AIML. How we are going to use the AIML in this. So we don't hard code this recommendation. Instead, we will use machine learning to constantly learn from them. For example, we can build a model that predicts battery degradation over the time trained on real world riding data. We can cluster the user information and personalize suggestion. We can even detect the outliners. Maybe a sharp edge is ahead. So that AI or ML can predict whatever is ahead of us. So this is how the modern industry is going to change. The proactive, data driven and learning over the time. So this competitive advantage doesn't come from just having high. It comes from how fast and accurate you apply it at the massive scale. So the next question is how the EV evolved over the time from for the past, current, and how the future is becoming. So let's zoom and talks about the industry because no solution exists in isolation. Believe it or not, EV vehicles actually are before the petrol cars with many models breaking records as you can see in 1800s also. But after that, the age of oil came from 1930s to 90. EV almost disappeared due to fuel chip, the slow battery development. Then the next era begins in 90s which many came with the hybrid of oil, both the oil and electric vehicles. And then the Tesla entered, which like transformed the market, proving that the electric vehicles could be cool, fast, and the high performance. By 2025, this is expected to cross the 20% of the global vehicle sales, and that's not just a technology shift; it's economical and industrial transition. So, what's the current state and what we can use in business opportunities? Let's see. The main and the key material is lithium ion batteries that are becoming with better energy density, but there is a geopolitical crunch in there. Like China holds most of the lithium which can be harmful for in future, so our company needs to make sure to include China in his business so we can sustain. Second one is fast charging infrastructure with more accessible. Third one, EV specific platform design with ground up. And the fourth and the most important one is smart connectivity, so it can increase the overall experience. So we can add that with subscription based features also. So what we can do from 10 years and now. So looking ahead to 2035, we can see there are many level 5 autonomous scooter will self navigate through traffic with the help of V2V technology. V2V stands for vehicle to everything. We can automate everything. And the second goal is to become the carbon neutral factories and they use the biodegradable parts. In India, there is target that we have to achieve the carbon neutrality all over the country till 2070. So our company needs to change that till 2025 because government will change the regulation. And third one is integration with energy ecosystem, battery revolution, and like in future there will be many technological changes like AR dashboards, voice assistant, and even the brain computer interfaces. And you can see this overall description of diagram that batteries, autonomous capabilities, sustainable manufacturing, ultra fast charging is very important. Like if you can charge in 10 minutes, then most of the people will use that. So let's wrap it up. On the other hand, we have many modern technology like AI, IoT. So we have to combine both of them. Like we have to balance the engineering with intelligence and with scale up with personalization. So our role, so as a future engineer and leaders, so we have to be ready for that. Thank you.
My name is Rachit Tripathi. So here the problem statement is data integration issues and solutions. The breakdown of the problem statement is the company is already collecting data in the cloud
Data is transmitted from the vehicle to cloud servers, updating an app with the data after analysis. Here we have to get the reasoning for the performance issues and the required improvement for the data integration. Inefficient data transmission protocol. The method or protocol used to send data from the scooter to the cloud might not be optimized. For example, if the system uses heavy or verbose data format like XML instead of more efficient ones like JSON or binary format like protocol buffers, it will take longer or use more bandwidth. Impact of this is the slower communication and delayed updates on the app. Second one is the cloud infrastructure limitation. The cloud system may not be capable of handling the volume of incoming data, especially during peak times. For example, if a cloud service are not set to auto scale, a certain spike in data uh, during rush hours could overload the system. Impact of this is the delayed processing, timeouts, or even app crashes. A third one is the poor network connectivity in scooter. If the EV scooter operates in area with poor mobile network coverage, it can reliably send data. For example, a scooter in a low signal zone might buffer data but not never successfully upload it until it's back in range. Impact of this is intermittent data availability and unreliable performance tracking in the app. Fourth one is the inefficient data caching and synchronization. When data is temporarily stored on the scooter or cloud and isn't synchronized properly or frequently. For example, if the cache size is too small or syncing logic is flawed, it might miss the delay uploading crucial data. And the impact of this is incomplete data analysis, missed update, and inconsistency in user experience. Fifth one is the lack of data prioritizations. All data might be treated equally regardless of importance or urgency. For example, diagnostic or critical performance alerts are sent with the same priority as less important logs clogging in the pipeline. Impact of this is a critical info may not reach the cloud app in time, affecting decision and user trust. Recommended data integration improvements are implement efficient data transmission, use lightweight optimized communication protocol and formats, use MQTT or gRPC for faster, lighter data transfer, compress data before transmission, before non-critical data to reduce frequency or transfer. Benefit of this is reduce transmission time, conserve bandwidth, and improve reliability. Second one is the optimized cloud infrastructure. Upgrade and scale cloud services to better handle incoming data and processing. How it does that? Use auto scaling features. For example, AWS Lambda Azure functions separate critical and non-critical processing workflow. Use load balancer and database indexing for faster access. Benefit of this is handle data spikes efficiently and improve speed of analysis and app update. Third one is the improved network connectivity. Strengthen the connectivity between the scooter and cloud, EV scooter and cloud. How it does that? Integrate fallback mechanism like local storage for offline periods. Use dual SIM or hybrid network. Uh, Place data relays or edge server closer to user. Benefit of this is prevent data loss and ensure seamless transmission even in poor network zones. Fourth one is enhance caching and synchronization. Store and sync data more intelligently. Implement delta syncing. Use persistent queues or buffer during network failures. Set up time based or event based sync triggers. Benefit of this is reduce app lag, ensure data accuracy, and prevent duplication or overrides. Fifth one is the implement data prioritization. Rank data based on urgency and importance. How we do this? For example, use tagging system or priority flags. Setup rule: send error codes immediately. Send location data every 10 minutes. Create multiple queues with different priorities. Benefit of this is ensure critical data is delivered first, improving user experience and system efficiency. Uh, Here is the visual representation of above two slides as shown there. Now the next problem statement is business and operational metrics. From both a business and operational perspective, to do this, they need to determine the right metrics and measurement that can reflect the vehicle performance, customer satisfaction, and market impact. On the business side, this includes tracking things like financial performance and market reach. On the operational side, it involves measuring aspects such as product efficiency, quality control, and delivery timelines. The core challenge is to identifying and using the most relevant metrics to assess how well the new vehicle meets company goals, align with customer expectations, and support sustainable growth. Here is some business matrices point wise. Revenue per vehicle. This measures the total income generated from selling one vehicle. It includes the base price plus any additional revenue from feature upgrades or subscription services. This metric helps assess the the company is able to extract per unit and indicate pricing effectiveness. For example, if the company adds premium feature, it can charge more and increase revenue per vehicle. Profit margin. Second one is the profit margin. Profit margin reflects the percentage of revenue that remains as profit after all costs such as production, marketing, R&D, logistics all are subtracted. A high margin shows the company managing its costs effectively and earning well from each sale. For example, if manufacturing costs go down due to improved design or economics of scale, uh, the profit margin increases. Third one is the market share. Market share measures the company portion of the total EV market. It's key indicator of how well the vehicle is performing against competitors. A growing market share shows that more customers are choosing this brand. More customers are choosing this brand over others. For example, gaining market share could mean the company is offering more appealing vehicle or better customer service. Sales growth rate. This tracks the rate at which the vehicle sales are increasing over time. It is useful for understanding the demand trends and how this EV vehicle is successful in the new model in a market compared to previous one. Sales growth. Sales growth rate. This tracks the rate at which the vehicle sales are increasing over time. For example, a sharp spike in sales growth right after launch can indicate a strong market reception. And next one is the customer acquisition cost. CAC is the average cost of acquiring a new customer, including marketing, advertising, sales effort, etc. A lower CAC means the company is efficiently attracting buyers, which is crucial for profitability and scaling. For example, if digital campaign or word of mouth drive a lot of sales, CAC can decrease. Customer satisfaction score, example NPS. This metric reflects how happy a customer are with the vehicle and how likely they are to recommend it to others. It's crucial for building brand loyalty, improving products, and driving repeat for referral sales. Example: a high NPS after launch suggests the vehicle meet or exceed customer expectation. Operational metrics. First one is the manufacturing cost per unit. The total cost to produce one vehicle, including raw materials, labor, and overhead. This helps to control the profitability, keeping production costs low without compromising quality, ensures better margin and competitive pricing. Second one is the product efficiency rate. This measures how effectively the production process convert input into finished vehicle. It's often expressed as a ratio of actual output to expected output. Higher efficiency reduce waste, speed up delivery, and minimize production bottlenecks critical for scaling production of a new EV. Third one is the delivery time. The time it takes from order placement to final delivery of the vehicle to the customer. Shorter delivery times improve customer satisfaction and operation reliability. Delay can hurt brand reputation and lead to cancellation. Fourth one is the quality metrics or defect rate. Track the percentage of vehicle or component that fail quality checks or are returned due to issues. A low defect rate ensures product reliability, reduce rework cost, and build customer trust. Especially important in a market where safety and performance are key. Next one is the battery performance. Include matrices like battery range, charge time, degradation rate, and efficiency under different conditions. Battery performance is a core differentiator in EV. High performing battery can play a major role in selling point and reduce customer complaints or warranty complaints claims. App performance matrices measure performance of the companion mobile app, load time, crash rate, data sync, reliability, and user engagement. This app is often used for vehicle control, navigation, and data tracking. Smooth app performance enhances the overall user experience and reflect brand quality. Next one is the sustainability metrics. Track the company's environmental impact, CO2 emission reduction, recycling rate, use of sustainable materials, energy usage in manufacturing. Uh, Sustainability is a major selling point of EV. Strong sustainability matrices aligned with regularity requirement and eco-conscious customer values. After sale service matrices. This one is the last one. Include repair turnaround times, service request, resolution rate, customer satisfaction after service, and availability of spare parts. High quality support build customer loyalty and boost word of mouth referral. Efficient after sales service also reduce operational disruption. With this, we conclude our presentation. On behalf of all our group, I sincerely thank for your time and kind attention. Thank you. Thanks a lot.